Solve the systems of equation. So notice that none of my leading coefficients or none of my x coefficients are 1. So I'm just going to keep the matrix the way it is. So remember, when we write these, we're just going to write the coefficients of each of the terms. To kind of help us see the matrix. So the first thing I'm going to do is I'm going to look at, remember this, row 1, row 2, row 3. So I'm going to look at row 1 and row 2. And I want to get rid of the first term. So in order to do that, I need to multiply the top row by negative 3 and the bottom row by negative 2. So if I do that, I'm going to get a negative 6, a negative 3, negative, and negative 3. And negative 6, negative 4, negative 8, and negative 8. Oops. I'm actually multiplying by positive 2, not negative. So that's going to be positive, 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 and positive. Because otherwise, if I multiplied by a negative 2, I would have had a negative 6, and then these won't cancel out. So I'm left with 0, 1, negative 1, and 5. Okay, so this is my new row 2. So now I'm going to look at row 1 and row 3. So I want to get rid of the x's. So notice I just need to multiply one of the rows by negative 1. And that's going to make them cancel out when I add them. So I'm going to have 3, 2, 4, 4, negative 3, negative 6, negative 4, negative 8. So when I add them, I'm going to have 0, negative 4, 0, negative 4. Now usually what I would do at this point is I would look at row 2 and row 3 and try to cancel out the y values, which are these 1 and negative 4. But if you notice, when row 1 and row 3, we already have two of the variables canceled. So right away, I don't have to do the third step, because I can just rewrite this as negative 4y. And the reason it's y is, remember, the first one represents x, the second one represents y, the third one represents z. So x is 0, z is 0. So I'm going to have negative 4y equals to negative 4. So y is going to equal 1. So then I'm going to go back to row 2. And I'm going to substitute my y. So I'm going to have 1y minus 1z is equal to 5. And I'm getting that from the row 2. So I know from this last step, y is equal to 1. So I'm going to have 1 times 1 minus z is equal to 5. So 1 minus z is equal to 5. I'm going to subtract 1. And then I'm going to divide by negative 1. So z is equal to negative 4. So the last step is using the original row, and I'm going to solve for x. So I know y is 1, and z is equal to negative 4. So I'm going to have 2x plus 1 minus 12 equals to 1, or 2x minus 11 equals to 1. I'm going to add 11. So I'm going to have 2x is equal to 12 divided by 2. So x is equal to 6. So my answer is going to be So my answer is going to be x equals to 6, y equals to 1, z equals to -4. So if you look at your answers, the only one that's there is x equals to 6.